Okay, welcome to Unit 9-2 of Algebra 2. How do you write rules for arithmetic sequences? Okay, here's an arithmetic sequence, 60, 80, 100, 120. Take a look at that. How would you get the next term? What's the pattern? Hopefully, you're saying, oh, all you're doing is adding 20. Adding 20. Okay, make sure to pause this video a lot. If you need to stop and figure those ahead of me, please do that. Okay, so an arithmetic sequence has a common difference between the two terms. I could be adding a value, which in this case I am, or the other thing that I could be doing is I could be adding a negative. So it could be going down, like it could be starting at 120, then 100, then 80, then 60, and I would be adding a negative 20. So the recursive rule on this, as you saw last time we dealt with recursive rules, we would say, well, our first term is 60. And then we would just simply say for all the terms in greater than or equal to 2, meaning once you get to here, it will be the first, I shouldn't say the first, the previous term plus 20. Okay, so when I get to the second term, I take the 2 minus 1, that would be the first term, and I add 20. That was the one rule that we didn't like when we were trying to figure out what was f of 50, meaning the 50th term. But it's an easy rule to get to. Okay? So now I want you to come up with the explicit rule. And remember, on the explicit rule, it was really nice because we could just plug in the term value and get what was happening over here. Okay? We are adding 20. And so if you remember right, from the rules, we knew that we would add 20 times something. And going with our explicit rule, we know this one is the first term plus 20. This one would be our first term plus 20 times 2, because it would be plus 40. There's 2 of them there. This one would be our first term plus 20 times 3, because there's 3 of those 20s to get down to that fourth term. Okay? So we could follow this pattern, and we could just say, oh, well, this is the first term, 20 times 0. Okay? That will get us back to our formula. So our first term would be 60. We don't need to write f of 1, we can give it, plus 20. And I hope you've noticed this value is just 1 less than this one. So in order to put it in a formula, we could just say n minus 1. Okay? Watch for patterns throughout all of these. They aren't too tough when you're just paying attention for the patterns. Okay, so let's go with a new sequence. 6, 9, 12, 15. First thing you want to look at, what's my common difference? Plus 3. Make sure it works everywhere. It does. So now to write the recursive rule, well, f of 1 equals 6. The f of n would be f n minus 1 plus the common difference is 3 for any value that's greater than or equal to the second term. Now for the explicit formula, we need to actually give the first term, which is 6, plus our common difference 3 times n minus 1. And that means on every single one, we could plug in what term number it is and get the value. If you're looking for a term way out there, like even 10, the f of 10, you would want to use explicit. Now, if you're looking for the very next term, just use recursive. Just to add it. You do it in your head. That's how you've probably always done sequences. Okay, so here comes a real-world problem. We've got a rafting trip that depends on the number of passengers as to how much they charge us. Okay, so we might come up with an explicit rule. Well, we know that our first term is I'll use black for the explicit rule. Actually, I'd write the sequence first. 75 for the first, 100 for the second person, 100 total. 125 if 3 people go. What would it be for 4 people? Do you see the pattern here? It's going up by 25. So if we have 4 people go, they're going to charge us 150. Okay? So the explicit rule would be to give the first term, so f of n would equal 75 plus 25 n minus 1. Okay, so we have 1 person going, 1 minus 1 is 0, so the first person costs 75. 2 people going, 2 minus 1 is 1, times 25 is 25, plus 75 is 100. So we got our explicit rule. That way we can figure out, hey, how many people need to go to make this trip really feasible for us? Okay, and it also, if you've got a whole party going, you can calculate really quickly what the charge will be without having to clear up the sequence. Okay, for a function rule though, since we've got it on a graph anyway, I wanted to look at this. If we extended the line, you notice what kind of function that is? Hopefully you're saying linear. Arithmetic sequences are linear functions. Get that down. Now you notice in the sequence form it was just dots there. That's because it's a discrete function. When I make it into a function rule, it becomes a continuous function. I extend that, and if I go with the same slope, I know that it's crossing the y-axis at 50, because 0 would be 50 when we gain 25 every time. So for the function rule, I would have f of x equals, my y-intercept is 50. Do you remember mx plus b? So all that I'm doing here, I'm just finding my y-intercept. I've still got the same slope, so it's 25x. So see, when I bring it back here, I've done the n minus 1 to the y-intercept, and so I keep the same slope. There's my 0 value. So that's how come I can convert that so easily. Okay? And then in that case, maybe I should show you this. You would put in the number of people going, like 1 person going, it would be 1 times 25 plus 50 is 75. You don't do the minus 1 when you put it into function rule. Okay? By the way, if you don't know that the connected line on a graph means that it's a continuous function, make sure to get that down with the notes where you said just the dotted lines are discrete. That's kind of an important thing to know. Okay, function notation. You've been using function notation for the explicit rule, fn f1 plus d times n minus 1 is function notation with the f. Now I want to introduce subscript notation. Same kind of thing, but we just use a subscript. So an is a1 plus d times n minus 1. Okay, so you're just showing that the position number is a subscript now as far as what term it is. Okay, each day a rain barrel is used for irrigating. May 6th, the barrel had 45 gallons. On May 11th, the barrel had 30 gallons. The water level is a arithmetic sequence. So if we think about this, day 1, day 2, day 3, day 4, day 5, day 6, we have 45 gallons. Day 7, day 8, day 9, day 10, day 11, we have 30 gallons. Okay? Write an explicit formula. Well, we don't have the first term, so the first thing that we're going to look at is we've got the 11th term, and we've got the 45th, the 6th day. So there are 1, 2, 3, 4, 5 days between them. So we can look at our slope, and 30 minus 45, I probably should have written that the other way. Yeah, I think I will. A6 minus A11 would be 45 minus 30. gives me 15. Okay, and this is term 6 minus 11 would be negative 5. So I am going down by negative 3 gallons. Negative 3 gallons per day. Now, I would look at my formula a to the n equals a1 plus d times n minus 1. And I would say, well, I know my sixth term is 45, so let's just put a6. I'll just put the value there. 45 equals a1 plus minus 3 times 6 minus 1 is 5. Okay? So we get 45 equals a1 minus 15. We add 15 to each side and we find that our a1 is 60. So now we can write our explicit formula because we have our first term. So it would be a(n) equals 60 minus 3n minus 1. That would be our formula. So that we know how much water we'll have in that rain barrel. You don't want to be using recursive to calculate how much water you've got for irrigation. You need to know explicit so that you know, hey, we got to have rain within a certain amount of time, or I got to fill it up another way. Okay? Have a great night. We will see you in class. Bring your questions.